Final question for Ruben? And please give a round of applause for Ruben. And then to our former intern, now at the Big Data team. Once in a while we also have a developer breakfast. The next session is a developer lunch. And during that session you presented something about this topic, right?
No.
No? Oh, okay. It was just a way for plugging the developer breakfast. And,
it might be a very good opportunity
yeah.
for that.
I thought someone mentioned that they heard your story there and said, "Oh,
no,
it should be a show." Okay, that was it all.
Like an ad hoc lunch.
Yeah. So you were having lunch with Paul,
yeah.
And then a really interesting idea for this talk came
yeah.
about. Please give a round of applause for us.
Yes, well, thanks a lot. I was indeed talking to Paul, which is our security engineer, about some new ways of setting up our big data platform. We're looking into refactoring that, of course, all the time, but now we want to split off some services there into a new AWS account in the cloud. So then you are going to rethink all the setup that you've done so far. And one of the things that's very common there, of course, is the SSH, which is basically how a developer accesses a remote machine in a way that he's sitting in front of it, but even if it's in cloud, he can do that from his machine here in the office. So that's a very nice thing, but historically it has always been kind of a challenge to manage that right. So for some background about the SSH itself, it provides a secure connection to remote machines. As I've told you, for the ones who have used it, it exists of a private and a public key pair. The public key pair is known to the other host. You keep the private key for yourself. And then it can serve two purposes. It can authenticate and authorize the client, so that's you basically sitting behind your computer on the machine. And the other way around, it authenticates the server to you as a client. Well, what does it look like? Probably for the ones who've used it, they recognize it. If you don't have the right key, then it just says permission denied. You're not able to access a machine that is remote. And to set it up the right way on the machine, so the lower entry is actually on the machine itself, not on the desktop, on the machine of the developer. In the authorized keys, you add your own public key. Then you're known to the machine, and if you're trying to log in, then using the way that's described above, then you're actually able to log in and you're in a session on that machine. So that's how it works for client authentication. Server authentication are these kinds of screens that probably everyone has seen. So the first time you log on, it asks you if you actually recognize that host and if you trust it to be added to your list of known hosts, trusted hosts. And then if something changes on the machine, it provides a warning and it actually warns you for stuff like man-in-the-middle attacks, which is what it is trying to protect you from. That works basically the same as in the authorized keys that you saw previously, but now on your own machine, you're at the remote service that you know to the known host, so it won't give you that message anymore. But actually, in a new era of cloud services, stuff like that, this actually provides some problems because you have to manage these two files, the authorized keys and the known host, which is usually done with Ansible, stuff like that, where you have to manage your keys. If a new developer enters your team, you have to add it to a list of known keys, developer keys. If he leaves, which is kind of the bigger challenge there, you have to remove it, and you have to make sure that it's actually getting removed on the machines as well, so he's not able to log in from his home and do stuff that you don't want there anymore. And actually, in the new cloud era, it can be that a certain IP is allocated to a machine. That machine is taken down, and then a bit later, a new machine pops up and actually has the same IP. And then you get these strange-looking warnings about man-in-the-middle attacks, where you are actually spinning up a new machine in a cloud environment, which is perfectly fine. It's just what you want. So there are some challenges here. And also there are challenges with the security of the keys. You don't have any insight in how a developer manages the keys on his own machine. There is no additional layer of security like two-factor authentication that you want to have there. So all this stuff makes the whole old setup kind of error prone. But actually there is a part of the SSH protocol that can support stuff like this, in which we have been looking into recently, and which is what I'm going to introduce to you, and that is SSH certificate authentication. So it's actually part of the Open SSH since 2010 already, so that's quite old, it's quite stable already, and it's used a lot by big companies, and it's promoted by Facebook on this blog that is just available online if you want to have a look for it. So it's actually used quite often, but it's not that well known, at least it wasn't known to me before I encountered that blog. So this is basically an opportunity to show you how it works. So the big point here is that there is a new entry introduced, which is the certificate authority, which you see here. And it must be managed, that's where all the user management is taking place. So that's a new point in the infrastructure that you have to manage and that you have to control. But it provides a lot of advantages. So the authority actually has a private and a public key pair. The red one is private and the green one is public here. Just like you have on your local machine, it's actually the same kind of keys, so nothing changed there. And how it works then, for instance, with client authentication, is first you have a server somewhere in your cloud which has a public key already, which actually it gets when it's starting up already, so that's not a big of a challenge to get it there. And then that server makes a request to the certificate authority. So basically what he's trying to do is, based on its public key, it's trying to get a signed certificate. Oh. Well, not showing it here, but it should be the case. It's trying to get the public key. Oh, sorry, I'm making a mistake here. So it's trying to get the public key from the certificate authority here. So that's something that's just publicly available. It's no problem at all to have it on the server. It's just can be known to everyone. But of course, there's a private key attached to that public key, so that can be used to authenticate users that are trying to connect to the client, to the server. So then a client, which has a private and a public key pair on its own, just like in the current situation that you already have, wants to get something that identifies him to the server as being trusted, and that's actually a certificate. So to get a certificate, the client makes a request to the certificate authority, and the certificate authority uses the private public key pair to sign that certificate. The certificate in itself is not private in any way, it's just public, and it's signed with the private key that's only known to the authority. But when that certificate is available on the client can then make a request to the server. And because the server has the public key from the authority, it can determine that the certificate that it's getting from the client is signed by the private key from the authority. So that's a way for the server to identify, without knowing anything about the client, without adding an entry in something like the authorized keys file, to authenticate the client on the server. The only thing is that both parties have to trust the certificate authority, so that is like the point that has to be secured. Shouldn't be available for anyone to create its own certificates, only via a controlled access path. And as you can see also, at the moment when the connection is made, there is no need for the authority at all. So that it's not a single point of failure of any kind. Once the client has a signed certificate, there's no need to contact the authority anymore. For the server authentication, it works the same way. So the server has a private and a public key pair of its own. It requests the authority to get a signed certificate there. And when a client wants to connect to the server, it gets the public key from the authority to make sure that they agree on the same private key that's stored in the authority without actually exposing the private key. And then it makes a request and it checks that the certificate is indeed signed by the private key that he has the public key from. So that's basically how it works. So the certificate authority now becomes a major part of the whole SSH setup. That makes for an additional management point, but it also introduces some nice additional features, especially in the cloud environment that we have now set up. So for instance, for this I created a Python library that is basically running in a Lambda, although because you have to use the SSH library, it can be run only on the Lambda, and I have to call Docker script as well. But the advantage here is that we can log everything that is happening in that Lambda function to, for instance, CloudWatch logs here. So we can see who is requesting certificates, which servers are requesting certificates, so we can trace all the user activity which is going on, centralized, so that's a big plus here. We also store actually the private and public key pairs in the AWS parameter store, which enables us to, if somehow the Lambda goes down or the Docker goes down, admin developers who have access on the parameter store can still run a local version of the certificate authority, can get their keys signed there, so they don't actually have to use a service in the cloud. That's only for the developer, for the admins. For the other users that want to use this, if you have them, they still have to go through the service in the cloud, because otherwise it couldn't be secured. And the other advantage is that we can integrate the Lambda. So on top of the Python library, there's a Lambda running, and on top of that, there's an API gateway, which is a service provided by AWS itself. And the advantage there is that we can closely integrate that into IAM. And you can see some advantages of that in a minute. For instance, stuff like the two-factor authentication. So let's close this one. Let's see what it looks like. So this is my machine. This is locally. I can show you here that I have a certificate already here, which I generated yesterday. And you can see that because there's a valid time range, which was yesterday evening. And you can see that it's only valid until 5 AM this morning. So actually, it's not valid anymore. So if I use that to connect to machine remotely, as expected, it says permission denied. Well, so the point now is that we have to get a valid certificate here on the local machine. For that, I created a small utility. I can show you it now quickly, and I will dive into the details later. But you can see that I'm using AWS Vault, which basically stores my AWS credentials with a certain profile, and then I run the Python utility locally. I want the client to be set up, and I point it to my public key on my local machine. So if I run that, it will show you the extra layers of security that are added here. So first, it will ask me to enter my AWS credentials. So this is normally stored in a credentials file on your machine. But in this case, I've added it to a vault, which adds an extra layer of security, because if you just enter my machine without my knowledge, by leaving my workspace, still have to enter a password to use those credentials. And here you can see it asks for an MFA token, which you go to add here. So that's just a one-time token to log in. And then it should all go well. It should take a while, basically, to API request, changing the files locally, and then everything's fine. No errors, so if I look into the certificate again, I see now that it is a new certificate, it has a different valid time range, actually it's valid now. So with this, I should be able to log into the machine. Here it asks again for the key on your private SSH key. So actually the normal levels of security that you want to have an encrypted private key on your local machine are still valid, still useful. You can't enforce this, but it is still useful for the developers to do that locally. And there we have logged into the machine. And as you can see, there's no message that the host is not known. So how is this set up? Well, basically, it all works based on a simple setup. So this is a CloudFormation template of how I set up the machine that I just tried to access. It's nothing very fancy here. It's just there is Ubuntu. It's just entered into there's an instance profile, which we will see in a minute is required to do the request to the API. But the interesting part is here. Using user data, we run a script where we simply get Python and out of date, we install AWS utilities, and then we download which I call the SSH utility that I created. We install it locally and we ask it to configure the host for host validation, client validation, and make sure that we have an authorized principal, which I will also show you in a minute, which says that we have a user, Ubuntu, and we allow everyone who has the group via admins in their certificate to access. So, to show you how it works, you see here, again, the content of the certificate that I created. You see here, all the principles here. So this basically identifies me on the host. And it says here which username I have, but also it shows two user groups. So the beta admin groups is the one that I find in the template here to be able to log into the Ubuntu user. So that's how it works on a remote machine. If I look into the SSH configuration, we have a folder called All Principles. And here we have the Ubuntu user, and every time the Ubuntu user tries to go in here, it opens this file. And there it is configured that the group via admins is allowed to access this user. So that's the way the user is actually authenticated on the host. Which makes it very easy to add certain user groups to this file and just make them available on the host. You can use different user groups. And these user groups, which is also an additional challenge of the way this is set up now, are actually managed from IAM. So what happens in the lambda function is that the username is passed on in the lambda function, and the username is used to ask AWS, hey, which groups is this user part of? And then, for instance, here you see the beta admins via SSH group. So it moves the user management from stuff like Ansible or whatever you're using to track your users to where you actually already are managing users, in our case, on IAM. And you just add a user group to make to allow the users to access hosts by SSH, which is a big plus there. Another thing is that the API gateway is the extra layer on top of the Python utility, and it's already neatly integrated with IAM and everything there. So you see here the endpoints that we have. You can have clients where you can ask for public key and get their public key to sign, and the same with the host. And for instance, here in the sign method, you can see that there's an auth method set up which uses AWS IAM. So it's not really custom that I have implemented. It's just the default way that Amazon provides to secure search endpoints. So the MFA additional, so the multi-factor application that you just saw is just provided by Amazon by default. And we also have defined the resource policy which says that on these endpoints to sign a client key. We deny anything that's not a principal and it's not a user as a principal client. Which means that, for instance, if you have a host that has a role that can access this API gateway, it's not allowed to get its certificate signed, its publicly signed because it's not a user. And the same, you can see here, that to get the client signed, you actually need the multi-factor auth to be present. So you can't circumvent it by being some kind of admin who doesn't require any multi-factor authorization. No, you get a explicit deny them, you have to provide multi-factor to be able to get your publicly signed. What does it look like on the client? So what does the via SSH utility actually do? Well, for instance, as I showed you earlier, in the old case, you had to add entries to the known host to be able to circumvent the message about the strange man in the middle of the text, stuff like that. So what it does now, it still has a known host file, but it adds new entries, which basically say that there is a certificate authority that we define. It defines a range or a wildcard for the domains that it's used for. So here, for instance, on the IP range, so 10.10.162, which is the range we use for all our instances. It says that if SSH encounters a request to get IP, it can use this public key for the certificate authority. So that's the way that SSH knows about the public key of the certificate authority, and that's the only entry that you have to add into your known host file to make this all work. And that's basically how the client authenticates the server. Well, that's basically how this works on this side. I'm also going to show you here. So the users here have policy text. Here is an SSH invoke client, which is an IAM policy, which actually so this is what allows users to actually invoke the API gateway. So, except for the case that you have this policy on either a group or a user, you're not allowed to do an actual call on the API gateway, or you're allowed to do a call with deny. So this way you can only allow certain users that want to have access on the SSH to have access on the API gateway. If they don't have access, they won't be able to get signed certificates. So that's the way to limit the access to the SSH via AWS provided IAM policies. It is a neat way to do that. So that's basically how this all works, how it's set up here. So the advantage for us is that we can manage the users from the IAM console in AWS. We don't have to go to the lengths to do some kind of Ansible setup to get public keys on different hosts. There's just one entry point everyone can use. Doesn't even have to be highly available because there are backups in the way of setting it locally for the admins. And that way, we provide us to simply set up the whole SSH infrastructure, allow us to access all the hosts that we have access to. We actually are using base images with the AMI at the moment. So it means that it's basically available in something like 40 seconds after the instances come up. So that's a really nice way, without actually invoking any Ansible play calls somewhere on a central machine. So that's really a big advance for us to speed up that process, properly manage all the infrastructure there, and set it up in a proper way. So that's how it works. If you have any questions, feel free to ask, and I'll try to get answers better.
You wrote the authority yourself? Because I think you mentioned you wrote the Python library.
Yeah. So basically, I didn't really write the authority. So it's all baked into SSH already. But I wrote the logic that calls the SSH keygen script, and the logic that translates like user groups to principals. Right. So there has to be some AWS calls to get the groups that a user actually belongs to. Those have to be translated to the principals that I showed you in the certificate. So that's the logic that I basically built myself, and the logic to simplify the local setup process. So the call now locally is only this one line, but what it actually does is that it already does the API call with your public key as like a parameter in the API call. It alters your known host, so your domain is set up properly, and you don't have to add that authority in your known host yourself. And the same utility is used on the server, so the 3 lines they showed you here. This is actually the same Python utility, but for the host, where it configures the host validation, so that means some entries in your SSH config and getting the public key from the authority, stuff like that. So it's all automated in that utility. But the secure setup, the signing of the certificate, stuff like that, that's nothing that I wrote myself because that's part of the OpenSSH array.
Cool. Follow-up question for the certificate. You basically keep them with a short time to live. That's your security because after one call, the certificate is not checked anymore. So you
no, that's true. Yeah, so it's basically the same as when you're using the AWS console. So you basically have a session timeout. And that's what the certificate represents. And if you're sure that everything is set up properly, so actually the certificate on the host looks exactly the same. So it has a valid range as well. So if you're sure that it's rotated often, you can set it very short. So we're actually planning to do it nightly. So your certificate only has to be like 26 hours valid. And for the client certificates, we only set it to about 8 or 9 hours. So working day. So developers can just sign it once, but the next day they have to do it again to get their access because it's all rotated again and the certificate is not valid anymore. Okay. So if it's set up properly, you're actually able to rotate it quite often, and then it becomes just a temporary password, basically.
So as a hacker, I have a window of 9.
Yeah, indeed. So yeah, and of course, still the responsibility to secure private keys and stuff like that still lays with the developer. But this ensures you that indeed, if you have an open window, or if you don't know that your private key has been leaked, it's only useful for a day because then the certificate is not valid anymore.
Good stuff.
Yeah. Any other questions? Well,
I think this is very interesting because you have one central place for logging, and it makes user authentication much easier. It's easy for the user.
yeah.
How would you see a migration path if other teams would like to implement this? Would it be a big bang scenario, or can you?
No, actually it doesn't because well, this is set up. The old way still works. So if your public key is set up in the authorized keys, then that still works as well. So you can start using this for some users or your power users that can do anything basically, and still leave the old public keys there to enable them to do it the old way, so to say. So there's no big bang required. It's just they can live alongside each other.
Sounds cool.
Yeah.
Are there any teams that would like to use this? Paul already wants to use it?
Yeah, that was also going to be my question.
Yeah.
Where can I get this?
Yeah. So actually the utility that's used for like client is a public repository on the Git. So there's nothing special here because it's just setting up everything locally. For the authority, so the certificate authority and the setup there, well, you can just contact me, of course, and I can refer it. So it's a Python library, but there is some stuff that needs to be set up properly. And I think some parts, because it's not thoroughly tested and stuff like that, some parts are specific for our setup at the moment still. But there is nothing that requires much work to generalize it. So it should be quite easy to distribute this across the company, I think. So feel free to contact me and
I will.
Yeah, we can have a look at it. Yeah.
Really cool, really nice work. Please give a round of applause. We now have a small break for beer and soft drinks. After that, we have a slight change in the schedule because Pim is not coming, so no React Native. So sorry for the people who are waiting for some front.